Welcome back to geometry. We're in unit 11, which is area and perimeter. So some learning targets here. What are composite figures? How do I find area and perimeter of various shapes or figures? And what is the difference between surface area and volume? You can see the vocab there. So we'll go over some of these terms and then go over some problems. So most of you have heard of area, or all of you have heard of area, the measurement of the space inside of a shape. So when you think about area, think on the inside, whereas perimeter is a distance around the outside. Now I will say that circumference will be considered perimeter as well, even though they use a different word. Now when we think about area, remember it's this measurement of the space inside. So we want to think squared units. Okay, so area is always squared units, whereas perimeter is just a distance. So it's just feet, yards, whatever the case may be. Now, with area and perimeter, we are talking about two-dimensional shapes. So flat objects, scale drawings, things like that. We'll talk about later on three-dimensional shapes, but we're really just talking about two-dimensional shapes with area and perimeter. So on your formula sheet, you should be able to look up some of these formulas. You can see most of them have a P and an A, one for perimeter, one for area, except for circles, but the C is kind of the same thing as the P. So we will be using these formulas. Now, if we wanted to find the area and perimeter of this, I'm just kidding. We're not doing rectangles. You guys have already done that. This is going to be about composite figures. So when we talk about composite figures, we're really talking about two or more shapes that kind of become one. So we'll have to learn how to divide these shapes into shapes that we know. Now you have to be careful. Area is usually pretty straightforward in that you can separate the shapes. Okay, but if I come up here and I draw, let's say, a semicircle on the edge of this, my perimeter is not the perimeter of the rectangle plus the perimeter of that semicircle, because this side right here is no longer part of my rectangle. So I have to be very careful about what I plug in. And is there stuff I'm missing? Is there stuff I need to add in? Things like that. So let's look at some examples. So for all of these, we're going to want to find the area and the perimeter. The ones I'm doing and the ones you're going to do. So there are many ways we could split this up. We'll start with area. Right away, I kind of see this way. And this is not the only way to do this. This is just the way I see. So I have a rectangle kind of on top that's 6 by 5. Okay, so the area that would be a rectangle is length times width. 6 times 5 is 30. And then I have this trapezoid down here. Okay, if we go back and look at the area of a trapezoid formula, which is this one in the top right, it's 1/2 times the height times A plus B, the top and the bottom kind of. Now, I don't know my height right away, but if I know this whole side is 10, and I know this is 6, then what's left over for this, 10 minus 6, is 4. Okay, so if I start to plug this in, area equals 1/2, I said, H, and then A plus B. So I plug in, H is 4. Now the A, we can call that like the top. It doesn't matter, but we'll call it the top. I know this is 7 right there, and I know this is 5. So the height, the base would be 12. The bottom base is 15. So I get that. So if I plug that into my calculator, I believe I get 54. So the total area would be 30 plus 54. And that's in inches. Everything's in inches. Inches squared because it's area. Now, for perimeter, what I'm worried about is the distance around the outside. Often it's easier just to add up all the sides than worrying about using the formulas. So let's start here. I have a 5, so I'll cross that off. I have a 10, cross that off. I have a 15, cross that off. I have a 7, cross that off. I have a 6, cross that off. But I'm missing this right here. I don't know what that is. So I need to find that. So believe it or not, in some of these problems, you're going to need to do Pythagorean theorem. Now I said down here that the top of the base was 12 and the bottom was 15. So that tells me that this leg would have to be 3, and I know that was 4. So really what I'm looking for is like my hypotenuse. So I could do a squared plus b squared equals c squared, which would be 3 squared plus 4 squared equals c squared. I would eventually get 5 for my hypotenuse using the Pythagorean theorem. So now I would need to add that into my perimeter. So 5 plus 10 plus 15, 5 plus 10 is 15, plus 15 is 30, plus 7 is 37, plus 6 is 43, plus 5 is 48 inches. So that would be my perimeter. Let's look at another one. We can look at this one. So I think about this as a triangle and a semicircle. So let's do area down here. So the formula for area is 1/2 base times height. The base and the height have to be perpendicular. Okay, since this was 11 and it's a radius of that circle, that would also be 11. So that means that the whole way is 22. So it'd be 1/2, my base would be 22, and my height is 16. So this is just for the triangle right now. So 1/2 or 0.5 times 22 times 16 is 176. Now for the semicircle, I only have half of the circle. So the area of a circle is pi r squared. My radius was 11, but I only have half of that. So I'm going to multiply that by 1/2. So 0.5 times pi, I like to use the pi button, but you don't have to, times 11 squared is 190.1. So if I add these up now, I get 366.1 centimeters squared. So that would be my area. Now my perimeter. This shape has really 3 sides. It has the semicircle and it has the 2 kind of triangular sides. So for the semicircle, I can use the circumference formula and multiply by 1/2 or divide it by 2. So I did it 2 different ways there, whatever way makes more sense for you. So if I do pi, 2 pi r is the circumference formula. So if I do 2 times pi times 11 and divide that by 2, I get 34.6. Now I also need to know these 2 sides. I don't know them. I need to do Pythagorean theorem again. So 11 squared plus 16 squared is going to equal c squared. 11 squared plus 16 squared is 377. So if I square root both sides, I get 19.4. So to that circle, I'm going to need to add in 19.4 plus another 19.4 because I had 2 of those. So 34.6 plus 19.4 plus 19.4 is 73.4 centimeters. So that would be my perimeter. I'll save that one for you guys. I think I need to do 2 more. Okay, I'll look at this one here. So let's start with area. There's a couple ways to think about this one. We'll put area up here. So how I'm kind of thinking about it right now is I have this triangle here. The triangle is 9 and 6. So it'd be 1/2 times 9 times 6, which I think would equal 27. Now I also, down here in this kind of shape right here, sometimes it's easier to subtract parts that are missing instead of add in different shapes. So I think what I'm actually going to do for this one, and I'm going to try to draw it over here, and it's nowhere near perfect. This whole top would be 15, 6 plus 9, and it says it down here. I know that was 9. This was Sorry, it's not writing very well here. This was 3. This was 6. So I think what I'm going to do is I'm going to do the area of the rectangle. So that would be 9 times 15. But then from that, I'm going to subtract, because I just want that kind of shaded in part, I'm going to subtract that triangle. Okay, so 9 times 15 is 135. But then I would subtract 9, so I'd get 124. So now I need to do 27 plus 124, and that would be, let's see, 151 units squared. I don't have any units, so I'll just write units squared. So it does get a little tricky there. So I took the triangle and I added the rectangle, but had to subtract another triangle from that. All right, perimeter. Let's see here. I need to know this. Let me use a different color here. I need to know this, and I need to know that. You're not always going to have to do Pythagorean theorem. I don't want you to think that, but these ones just happen to be. So if I solve that, 6 squared plus 9 squared, and then I take the square root of that, I get 10.8 for this. If I do this one, it would be 3 squared plus 6 squared equals c squared. So square root of 45, and I would get 6.7. So for perimeter, I can do 9 plus 6 plus 6 plus 10.8 plus 3. Nope, not the 3, right? That's not actually part of my shape. Plus 6.7. Now, I did forget. Look, I didn't put this in there, did I? I think that would have to be 6 because this is 9, the whole thing, minus the 3. So I do have to add in that 6. And then this right here would be 9, 15 minus 6. So I think I got everything. I got the 9, got the 6, got the 6, got the 10.8, got the 6.7, the 6, and then the 9. So if I add those up, 9 plus 6 plus 6 plus 10.8 plus 6.7 plus 6 plus 9, I get 53.5 units. All right, last problem here. We'll do this one. So the front of a garage needs to be painted. The total area except for the door will be painted. The door is 1.5 meters high and 2 meters wide. So what did it say? 1.5 high and 2 meters wide. How many square meters of paint will be needed? So I'm going to separate this into a triangle. And I don't think I even care about perimeter here. Triangle and a rectangle. So this triangle would be 1/2. The base would be 3.5. The height is 1.2, it says. So the triangle, 0.5 times 3.5 times 1.2 is 2.1. Now, this rectangle, I have to subtract the garage door. So the rectangle, I'll change colors here, would be 2.5 times 3.5, sorry. Height and length, but I'd have to subtract the garage door, which is 2 times 1.5. So 2.5 times 3.5 is 8.75 minus 2 times 1.5, which is 3, so 5.75 for the area of that. So I'll do 1.2 plus 5.75, and that should give me 6.95 meters squared. Okay? If each can covers 2.5 square meters, so I need to do 6.95 divided by 2.5. It gives me 2.78, but I can't buy 0.78, so I would need 3 gallons. If each gallon is 24.50, 3 times 24.50 should equal $73.50. So as always, if you have any questions, feel free to ask in person or email. Go back and watch these, find other examples, and hopefully you do well. Have a good day.